Today we're going to talk about the periodic table. We're going to talk about different trends that you might see in the periodic table, and we're also going to talk about why it looks the way that it does. The periodic table was developed in the 1800s by a man named Dmitry Mendeleev. Now you don't have to remember that name, but if you do see it, you should be familiar with it. Mendeleev was a Russian scientist that discovered certain trends when you looked at elements. He organized these elements according to their chemical properties. A chemical property is basically how an element reacts with another element. For example, a chemical property of sodium is that it is very highly reactive. It also explodes in water, as does potassium. And you saw both of those happening in this very classroom. So Dmitry Mendeleev organized this periodic table according to the properties. And in the original periodic table, he didn't develop or identify any of these elements here. He identified groups 1, group 2, group 13, which used to be called group 3, 14, 15, 16, 17, and 18. The periodic table was much smaller. Now he organized the periodic table into what is called groups because they have the same valence electron, and because the valence electrons are the same, they're going to react in exactly the same way. For example, group 1 wants to get rid of one valence electron to form a positive ion, and group 17 wants to gain one valence electron, so they have an octet. As you could probably figure out, group 18 has a full octet, a complete valence shell. They don't want to gain or lose any electrons. That's why they're called noble gases. Noble gases don't react. According to the periodic trends, as you go up and down a group, the number of orbitals is going to change. Group 1, period 1, periods go across. Group 1, period 1, 1 orbital. Group 1, period 2, 2 orbitals. Group 1, period 3, 3 orbitals. Group 1, period 4, 4, and so on and so forth. As you go across the periodic table, the only thing that is changing is the number of valence electrons is increasing. Period 3, 1 valence electron, 2 valence electrons, 3, 4, 5, 6, 7, 8. It gets a little tricky down in here. These are the transition metals, and they don't follow the same trends as the rest of the metals. We're going to talk more about these transition metals later. So there are 3 types of elements, so to speak, in terms of metallic properties. We have the metals. These are all metals. We have the nonmetals, and we have the metalloids. There's a staircase you'll notice in your periodic table. Any element that touches the staircase, with the exception of aluminum, is a metalloid, which means they have characteristics or properties of both metals and nonmetals. Metals like to lose electrons, nonmetals like to gain electrons. Noble gases don't want to gain or lose any electrons, but they're still considered to be nonmetals. They're also, every single element in group 18 is a gas.